All right, so in this video, we're going to be looking at how you find the pH of a salt solution. We already talked about how salts can affect the pH by making them more acidic or more basic. In this case, we're dealing with sodium fluoride. So with sodium fluoride, the sodium will have no effect because sodium hydroxide is a strong base, so its conjugate, sodium, will not have any effect on the pH. But the fluoride ion will affect the pH because hydrofluoric acid, HF, is a weak acid. And so when it reacts with water, it will form an equilibrium with the fluoride ion, which is the conjugate base, and H3O+, hydronium ion. Okay, so since the fluoride ion is a conjugate base, we're not dealing with hydrofluoric acid this time, we're just dealing with fluoride ion coming from this salt. But the fluoride ion, when put into water, will act as a base. So it's going to take a hydrogen away from water, so it'll make HF plus OH minus. All right, so we were given the Ka value for this equation right here. This has a Ka, which is for this equation, hydrofluoric acid acting as an acid. It has a Ka of 6.8 times 10 to the negative 4. And so we can find Kb for its conjugate. If we remember the relationship between Ka and Kb, Ka times Kb is equal to Kw, and Kw is 1 times 10 to the negative 14. So we have 6.8 times 10 to the negative 4 times Kb. And so we can solve for Kb, and we find that Kb is 1.47 times 10 to the negative 11. So this is Kb, and that refers to this equation, fluoride ion acting as a base, okay? Because fluoride ion is the conjugate base of hydrofluoric acid, and so if we knew Ka, we could find Kb. All right, well now with that information, we're going to make an ice table. And we're going to calculate the equilibrium concentrations when you put fluoride ion in water. So the first thing I need is the concentration. So I had 10 grams of NaF. So I'm going to find the molar mass, which is 42 grams of NaF for every 1 mole. So that means that I have 0.238 moles of NaF. I don't really care about the NaF, I just care about the fluoride, but I have 0.238 moles of fluoride ion. And what's in 1 liter of solution, so our molarity of fluoride ion is 0.238 molar for the fluoride ion. All right, so that's my initial concentration of fluoride ion, 0.238. We don't care about the water. These are starting at 0 and 0. All right, so if we put this molarity of fluoride ion into water, it's going to take some hydrogen away from the water, and that's going to increase the concentration of hydroxide. We want to figure out how much it increases that, so we'll call that X. That'll change by the same amount. And this will decrease by X, so 0.238 minus X. All right, we'll write out our equilibrium expression. So Kb, because this is an equation for a base, is equal to, so we'll have HF and OH minus on top. And on the bottom, we'll have the fluoride ion. We found Kb using Ka. 1.47 times 10 to the negative 11. So hydrofluoric acid is X, OH is X, and then this number, so we can make our calculations a little bit simpler knowing that X is going to be really, really small since K is really, really small. So this will be about equal to 0.238. And if we say that, it'll save us a little bit of effort in our algebra. So 0.238 will be the concentration of fluoride ion. All right, so we will solve for x, so multiply both sides by 0.238, and then take the square root, and we'll find that x is equal to 1.87 times 10 to the negative 6. What does x mean? Well, x was the concentration of hydroxide. So with the concentration of hydroxide, I can find POH by taking the negative log of 1.87 times 10 to the minus 6. So my POH comes out to be 5.72. And from POH, I can subtract from 14 to find pH. And so my pH ends up being 8.27. Okay, and so that will be the pH of this solution. It makes sense because it's a little bit basic, and we know that the fluoride ion is a very, very weak base, right? It has a Kb of 1.47 times 10 to the negative 11. So it is a base, but it's a very weak base. And so adding a salt containing fluoride to water affects the pH. It makes it a little bit higher, a little bit basic, and that's how you calculate it.